Hello everyone. In this video, I'm going to present my undergraduate final project, which was on Sustainable Mobility System for Silicon Valley, SMSSV, also known as the Spartan Superway. The SMSSV, or the Spartan Superway, is an interdisciplinary student-run project with the goal of developing a solar-powered rapid transit system to be implemented in busy urban areas. The goal of this project was to design a system that will be able to provide a renewable energy-based transportation system to the public while minimizing the system's overall environmental footprint. And the initial prototype consisted of pod cars like this, suspended from structures similar to rail lines, which will be covered with solar panels, as you can see here. And the pods will mostly run on energy provided by these panels. These lines will run all through busy cities. So we have worked with the vision of creating a city we see in movies like sci-fi movies made into reality. As part of the SMSSV project, our team of electrical engineers have created a solar interface that will supply power to the Spartan Superway and utilize solar energy to offset environmental impact of the transportation system as a whole. So this was our whole group here, and that's me. As I mentioned, it is an interdisciplinary group where almost 35 mechanical engineering students work every year, and the electrical engineering group of 2016 that I was a part of had 3 EE students, including me, and I was fortunate enough to be a part of them. So the automobile transit in busy cities is rapidly becoming unsustainable due to the increasing population all over the world. The increasing number of automobiles are worsening the environmental impact of fossil fuel combustion in a very alarming rate. And in this alarming situation, our pod cars can be the final answer. It will bring us closer to the green future that we all dream of. And of course, all of us are familiar in this scenario here where most of our time is wasted on traffic every day. And therefore, for busy cities like most cities in Bay Area, our pod cars will provide the fastest, affordable, and reliable public transit for everyone. So here are some of the goals of our electrical engineering team was to design a power system that will include DC to AC conversion to utility supply, and then also DC to AC and then back to DC conversion for auxiliary loads, which I will talk about in the next slide. And of course, the main goal was to utilize the solar panels as much as possible. So this is the design that our team developed to power the whole thing. An array of 15 solar panels provided approximately 1 kilowatt of peak power to a grid tie inverter. The inverter has a synchronization circuit that produces an AC output that is phase matched to the AC provided by the utility source. So this will feed the city grid. Connected to the utility source along with solar inverters is a battery charger. The charger output is connected to the storage batteries that are inside the pods and the wayside fixed conductor rail here. The transport vehicles have a movable conductor as well, as you can see here, which rides along with the fixed conductor to provide an input path to the various loads inside the car. So the nominal 48 volt DC on the wayside rail will power the drive motor controller and a second 1500 watt inverter unit as well. The second inverter unit provides 120 volt AC and 60 hertz for 1250 watt ATX power supply here, which provides a 12 volt DC and a 5 volt DC for auxiliary loads, such as the suspension and steering motors inside the pod. Also powered by this end unit will be multiple microcontrollers that independently operate the various subsystems of the vehicle. So this was the whole design that we came up with. And these are some of the actual components that we implemented inside the full-size model, the ATX power supply and the power meter, and I'm not going to go into details on inverters and things like that. And as you can see, we were successfully able to provide the 5-volt DC and the 12-volt DC as we promised to the team successfully. So these are some of the design advantages that we have implemented. Our design allowed for direct integration of solar power, and we have created a system with multiple sources of power and provide multiple sources of 5-volt and 12-volt to the pod cars. And all of this were very beneficial to implement as much of a practical design as possible. So if you want to know more about this project, here is the project website where you can find a lot of details. For example, you can know more about the people that have worked on it. It also has a little biography of mine here. You can see the sponsors that are cooperating with this project, the current project goals, and the current project developments and details like that. And one of the most exciting part of this project for me was to be able to present our work at Maker Faire of 2016. So every year students present the actual model of Spartan Superway at Maker Faire, which is one of the biggest and greatest tech fairs of Silicon Valley, as you probably know. And here is a link to the blog that has the details of our work presented at Maker Faire, the Maker Faire that I attended. Also, there are several news articles on this project, and this is a link to the news article that China Global TV Network has made on Spartan Superway, so you can check out this video. It has nice summaries on the current goals and interviews of students and professors and details like that. So this was the project I have worked on during my last year of undergrad as an EE student. And I have enjoyed sharing this with you guys, and thank you for your time.